So before we start our pop quiz, we can't even do the pop quiz until we understand the directions. Below are several statements about the properties of rational expressions. You've heard both of those words before. I know because I've said both of them, but it doesn't help if you don't know what they mean. So before we even start this quiz, I need you to tell me what rational means. Let me help a little bit. What about that? What does that mean? Ratio? Proportional? How do I write a ratio? As a fraction. Guess what the word rational means? A fraction. It's a fraction. What's an expression? Or maybe it's a better way to ask it is, what's the difference between an expression and an equation? An equation has an equal sign, an expression does not. Okay? An equation has an equal sign, an expression does not. So, people were confused earlier, which I totally get, because look, this has an equal sign. But I'm saying this is what I know, and this is what I think it is equal to. Do you see the difference? Yes? This is the expression, this first expression, that's what we're talking about. Okay? So, true or false quiz, which means we've got to answer all 8 of these questions, true or false. 5x over x equals 5 because you can cancel the x's. Is that true or is that false? So I'm hearing a lot of truths. This would be the reason it's true. Just because there's a reason over here doesn't mean that reason is really making it true. That's the reason that some people give for it to be true. Okay? What can you cancel? What kind of things are you allowed to cancel? Starts with an F and it's not the bad one. Factors. Factors is what you're allowed to cancel. Is 5 and x factors? How do you know they're factors? They're being multiplied. Okay? When they're being multiplied, they're factors. So, what is x divided by x? 1. Am I allowed to simplify something that equals 1? Yes. So, in this case, does 5 equal 5? Then that is true. Okay? What about number 2? 5 plus x over x equals 5 because you can cancel the x's. Why do you think it's false? Okay, so if I canceled this, you think that would be a 1 and 5 plus 1 would be 6 and not 5? You're right, but for the wrong reason. It's a good guess. You can't cancel out. Let me repeat what you said. Say it again. You can't cancel out the x because 5 and x, this 5 and this x are not factors. Agree or disagree with him? Because I agree with him. Okay? You cannot cancel these x's because this x is part of another number. It's not a factor of a number. Okay? So this is false. And don't do one of these weird things like that so you can't tell whether it's true or false. I know your tricks. I know your tricks. I can tell you again why it's false. Because this x is part of this number. It's being added or subtracted to part of that number. It's not a factor of that number. It's not something that's being multiplied. Correct. Okay? All right, let's look at number 3. These two things equal each other because the negative 2 and the positive 2 cancel. These two things can cancel. What do you think? Sure? You think sure? Oh, true. Okay. When can you cancel something? If it's a factor. Those things are being multiplied by everything else? No. They're not being multiplied times the whole rest of the number. So are they factors? No. So can you cancel them? No. This is false. I have to show you something silly. Okay? Because once you guys figured out they're not factors, you guys were like idiots. That's a stupid thing to do. Except, let me show you this. If you can cancel out these 2's like that, you can cross out like part of a number. You can also simplify this number by crossing out the 1's. Can you simplify that by crossing out the 1's? No. And you could also simplify it by crossing out those tall lines. So your answer is this. You guys think that's ridiculous, don't you? You think it's like even possible, right? That's what I think sometimes when you guys try to cancel out the 2's. It's not even possible. And this is as silly as it is. Mathematically, that's the same silliness. You trying to cancel out these 2's. They are not factors. They are part of a number. These are parts of a number. That is not even a number. Okay? I know that this is ridiculous. I'm trying to give you something to latch onto that you will remember that you can't just cancel out a number in the numerator and a number in the denominator just because they're the same number. Okay? Just like the 1 and the 1. The vertical line of the 7 and the vertical line of the 9. Okay? What about number 4? This says it's true because when you have fractions, you multiply across and the x's cancel. How do you multiply fractions? What do you do? The only time you ever cross multiply is when you have one fraction set equal to another fraction. Is this one fraction set equal to another fraction? No. So how do you multiply fractions? Straight across the numerator, straight across the denominator. Is that what happened? If it's what happened, then we got 24x over 5x. And then they did what with the x's? Are you allowed to do that? Why are you allowed to do that? Because it's a factor. It's something being multiplied by the 24. It's something being multiplied by the 5. Okay? Now I had to blow your mind a little bit. You ready? Why can't I cancel these x's then? Because I just said you can cancel these, and it's a number times an x, so that's a factor, and a number times an x, and that's a factor. That's a 3 times an x and a 5 times an x. Why can't I cancel these x's? But there's 24 here and 5 here. Why can't I? You cannot cancel these x's. I want to know why. These things right here are alone. These things up here have things added or subtracted to them, which means they're not factors. It's still just part of a number, just like this over here. Okay? So number 4, this one is true. Okay? Questions? Look at number 5. What's happening here? Addition. You can tell because of the plus sign. Yeah. 1 over x plus x over 4 equals 1 over 4 because you can cancel the x's. Brandon, I think you're the one that said it a second ago. What do you have to do when you add fractions? Maybe it wasn't you. Maybe it was just somebody at your table. What do you have to do in order to add fractions? The only time you ever cross multiply is when you have one fraction set equal to another fraction. What do you need in order to add fractions? You have to have a common denominator. Does this say, does this statement make it true? Do you just add straight across and cancel the x's? No, that is false. So what about number 6? Because you can add straight across. Can you add straight across? What did we just decide? No, that is false. So that means number 7 is also false. Oh wait, what? They have a common denominator, and what do you do with the denominator? You add the denominators up? Oh, you keep the denominator. And then what do you do with the numerator? You add them. Guess what this one is? True. Guys, I don't want you to worry too much about these 4. I know we're about to do number 8, but I don't want you to worry too much about these 4 because guess what we're doing next Tuesday? Look. What does it say on the board? What are we doing next Tuesday? Adding and subtracting fractions. This will make more sense on Tuesday. Okay? When graphed, both have the same asymptotes. You don't know what that means yet. We haven't gotten there. I have told you about it because I've told you how to not use the word. Okay? It's enough right now to let you know that it is true because when you do graph it, they do have the same asymptotes. This side of the equation and this side of the equation, each expression, when you graph it, it has the same asymptotes. But again, we'll talk about that eventually. Fair enough? Okay. So I need you to be able to simplify some expressions. Before I have you simplify some expressions, we need to fill out some vocabulary stuff at the top. Okay? You can make equivalent fractions. Let's start here with the 2/5. Let's start with the 2/5 and go to the 40/100ths. Okay? How can we make equivalent fractions? How can I get from 2/5 to 40/100? What do you think? Multiplying both sides by, in this particular problem, we multiplied both parts by 20, right? But that's real specific to this problem. If we wanted to be a little bit more general, we could say by multiplying both parts by the same thing. Does that make sense? So you can simplify fractions from going from the 40/100 to the 2/5 by dividing both parts by the same thing. Thing is really a bad word to use. What word should I use instead? Same number, the same, because it's not always going to just be a number. Maybe same factor would be okay. Okay? The same value would be good as well. Okay? Are you okay with me saying thing for now? We can always correct our vocabulary as we go on, right? Okay. So what if we were starting here and going to this thing? How can I make equivalent, equivalent what? You can make equivalent blank expressions. Oh my gosh, rational, good job. Rational expressions. Wait, and what does rational mean? A fraction. You can make equivalent fractions. Oh my gosh, that's exactly what it said up there, right? By what? Multiplying both parts by the same thing. Excellent. This one's a little bit different. Do you notice that? We're going from here to here. Looks like, what did we do here? What did we do from this step to this step? What did I do from this step to this step? I noticed each term was divisible by 2x, so I divided it out, right? And so I broke this into its two parts. So I could simplify a rational expression by, what do you think? Dividing common, close. Factors. You ready? Look at number 1. 8 over 4x minus 12. If we're going to be dividing out common factors, what do I kind of need to do first? I kind of need to factor, don't I? I need to factor the numerator and factor the denominator to see if there's any common factors. I got to know the factors before I can know if anything's common, right? Okay, so can't really do anything to the numerator. Can I do anything to the denominator? I can divide both terms by 4. So if I pull that 4 out in the front, what do I have left? X minus 3, right? Because I need to divide each term by 4. Now what if I wrote it like this? Am I allowed to write 8 as 4 times 2? Good question. Why would I do that? What am I allowed to simplify? Common factors, right? I'm allowed to simplify common factors. Does the numerator and denominator have a common factor? What is it? 4. 4 divided by 4 is 1. What's left? 2 over x minus 3. Some of you can see clearly that 8 is 4 times 2 in your head and can actually totally skip this step as far as writing it down. You're doing it in your head, but you can skip it. Some of you need to write this step for now until we get it figured out. Fair enough? Look at problem number 2. First step that I really want to do is factor. Can I factor the numerator? Not really. Can I factor the denominator? It has a common factor, so what is it? 3. If I factor out of 3, what's left? 2x plus 5. Okay? Can I try to trick you? So early on, can I try to trick you? It is wrong. What's wrong with it? Isn't there still a 1 in the numerator? Isn't 3 divided by 3 a 1? Isn't there a 1 left there? So isn't it really 1 over 2x plus 5? Guys, you can't just ignore it. A second ago when I said 4 divided by 4, I think it was right here, somebody said 0. Is something divided by itself 0? No, it's 1, isn't it? Okay? So we need to be careful to remember that there is a 1 left up there. Right? Look at number 3. Can I simplify the numerator? Factoring it. Nope. Can I simplify the denominator by factoring it? How? Each term is divisible by x. If I factor an x out of each term, what's left? X minus 3. So what should I do? Quit and go home. It's not an appropriate answer. What can I do? I can cancel out the x's, right? I can simplify the x's because x divided by x is 1. So let me ask you this. Does it matter which x's I cancel out? Can I cancel out these two? It's in parentheses. That makes this x not a factor. It makes it part of this x minus 3, right? So does it matter which x's I cancel out? Yes, it does. It has to be this one and that one, doesn't it? Absolutely. Absolutely. That's exactly what it is. Okay? Any questions so far? All right, let's look at number 4. Can I simplify the numerator by factoring? Oh, I can this time. Okay, how do I simplify it? They're both divisible by 4, so if I divide out of 4, what's left? 2x plus 3? And can I simplify the denominator by factoring? Okay, what's left? What's common? Of 4, what's left? X minus 3. What can I cancel, if anything? 4's and the 3's? And the x's? Why can't I do the 3's? They're inside the parentheses. They're not factors. What can I cancel out? Only the 4's. Are you sure I can't go ahead and cancel out the 3's? Very good. Yes, you're sure. You should be sure because we cannot cancel out the 3's. Even though they're not in parentheses anymore, they're still part of that number. They're not a factor. They're being added or subtracted to something else. Fair enough? All right. Look at number 7. We'll do number 9 after we do number 7. If we have time. That's what I'm trying to get to. We're doing number 7. So in the numerator, 4 is the common factor, right? So if I factor out of 4, what do I have left? X plus 2. Right? What about the denominator? I have to factor that, don't I? Can I just say what multiplies to be negative 4 and adds to be 4? No, because that's not a 1. So I have to, I'm going to give myself a little bit of room to work, and I'm going to come down here. Now I have to find out AC. What's AC? Negative 12. What's B? 4. What two numbers multiply to be negative 12 and add to be 4? Well, 1 and 12, 2 and 6, 3 and 4 are the ones that multiply to be 12, right? With one of those being a negative. What's going to add together to be a positive 4? Negative 2, positive 6. So I'm going to rewrite this problem. 3x squared plus 6x minus 2x minus 4. Why did I write the 6x and not the 2x first? Because I accidentally already wrote a plus sign. That's honestly the reason. Okay? Remember when we talked about this, it doesn't matter which one of these go first. So now look at just the first two terms. Factor by grouping. Just the first two terms. What's what's common in the first two terms? And 3. 3 and x. What's left when I divide by 3x? X plus 2, right? Now look at just the last two terms. What's common? What happened to the squared? Well, remember 3x is the same, squared is the same as 3 times x, right? And if I took one of those x's out, I have an x left. Okay? So what's common in the last two terms? Negative 2. What's left over? X plus 2, right? If I'm taking out a negative 2. So what did they have in common? An x plus 2. And what did I factor out of each term? A 3x and a negative 2. So guess what that is? That's the denominator. So now what? What am I allowed to cancel out? What am I allowed to cancel out? Factors, right? I'm allowed to cancel out common factor. Is there a factor in the numerator that's also in the denominator? What is it? An x plus 2. If I cancel it out like this, I'm allowed. If I cancel it out like this, I'm allowed. Yes. Now, keep in mind, please understand that I did not cancel out the x's and then cancel out the 2's. I didn't, did I? I canceled out the whole x plus 2 and the whole x plus 2. So I do get 4 over 3x minus 2. Let's do 8. Factor number 8. Can we do our shortcut on 8? Is that a 1? Yes, so then what multiplies to be negative 14 and adds to be negative 5? Negative 7 and positive 2. X minus 7, x plus 2. What about the denominator? Can I do my shortcut on the denominator? Yes, because that is a 1, right? What multiplies to be 12 and adds to be 8? X plus 2, x plus 6. What can be done, if anything? X plus 2 and x plus 2. The whole term. So what's left, boy? X minus 7 over x plus 6. That's it? Okay? To be clear, you guys are doing 1 through 9 on the back. Which means these 3 right here can be counted as extra credit if you do them. The ones on the 3 we didn't do on the front. The first one that we did, the pop quiz, this will be in notes. Is everybody listening? This worksheet right here will be in notes. This will be in homework. The simplifying rational expressions. Any questions? Any questions about the lesson?